All right, welcome to Rapid Fire Manufacturing. Today I have Brian Shaw with me. He is the sales director for Andritz Metals USA. You know, in steel manufacturing, it's more than just pressure and heat. There's precision, problem solving, and keeping the industry moving. And Brian Shaw has been in the trenches working across melting, rolling, forging, and machining. So he knows what it takes to keep the mills and service centers running at their best. Brian, thank you so much for joining today.
Thanks, David.
And every time I see your name, whether we're emailing, I always think of Brian Shaw, the strongman. So I don't know if you've gotten that before.
I have, yes. Yeah.
Yeah,
Although, as you can clearly see, that's not me.
you're moving coil around. So
That's right. Yeah.
yeah, you've worked across melting, rolling, forging, and machining. Where do you see the biggest untapped potential for process improvements in the steel manufacturing?
I guess I thought about this a little bit ahead of time, and I think one of the things that we can do is capitalize on some of the modern capabilities, particularly in the area of predictive maintenance. For all of those operations, maintenance is absolutely critical. If you don't have a good maintenance plan or a good maintenance team and tools and all of that, you're going to go down really quick. So it's such a
Mm-hmm.
critical part of it. And we're more challenged today more than ever for doing that maintenance because in-house resources that used to be plentiful in the past, whether it was people or skills of the people that are doing that maintenance, they're just not as plentiful as they once were. So being able to use sensors and other monitoring tools and equipment on any one of those operations to use it as predictive maintenance, not just preventative. Preventative is part of it, and that might mean
Mm-hmm.
I'm going to schedule a change for a bearing or something every 6 months. Well, maybe the reality is that that bearing could actually go for 9 months or 10 months, but you're changing it 6 months because you're trying to be preventative and avoid a more catastrophic scenario. But if I have a sensor on there that says this is going to fail in the next 3 days or something like that now, or even 3 weeks, you can really dial in some best opportunities for maximizing the usage of your equipment that you have, whether it's a rolling mill or a machine shop or something like that. So I think utilizing that technology that's becoming more and more available is a big opportunity. Of course, it requires a little different skill set than some of the past maintenance practices, but that's the
Mm-hmm.
adaptation that I think we need to do moving forward.
Yeah, and I like how you break that. You differentiate between predictive and preventative because I would imagine that downtime for that maintenance that's costly, right? So if you're able to get 3 more months out of a bearing, I mean that's huge for not having to take apart a machine and replace stuff. Right?
Sure, absolutely. Yeah, it's anything you can do to keep the equipment running more is always beneficial. That's more money coming in and that's better cash flow coming through your business.
Yeah, absolutely. Now, and I know you've talked about this when we had lunch the one day. So you've been deep in metallurgy and quality for years. What's some failure analysis case that's really kind of pushed you and developed your problem solving capacity or skills?
I would say it's of course the ones that are the most elusive. So I think when you're looking at an indication or something, some nonconformity in a product, and it's gone through multiple processes. So, it's been melted, it's been rolled, or it's been forged, it's been machined, and you're finding this, close to the end of that. Now you've got, sometimes it's obvious, but when it's not obvious, you might have to think back through every one of those processes that it's been through.
Hmm.
And I think some of the large size open die forgings sometimes can be the most difficult because one of the standard inspection methods for that is going to be ultrasonic inspection. So you're looking inside that piece of steel or aluminum or whatever the metal is, and you can't actually see what you're finding in there. So you have to take that and size it up, look where it is in relation to the rest of the piece of the metal, see where that could have been introduced into the process, how far below the surface is it. And so kind of backtracking all those different steps can take a lot because ultimately you want to be able to still use that piece of material for its end application, and you can't cut that apart and then you're going to jeopardize the part. It's no longer going to be what it was originally intended to be made for. Ultimately, if it's rejected and you can't pass it, then you have the opportunity to actually dissect that piece or cut it apart and then really physically look at it. But when you can't physically look at it, that's when it's a little bit more challenging. And then sometimes it's a matter of getting the customer involved to say, hey, look, we have this defect or this inclusion that we found at this point. Is this going to be, a problem for you guys? And sometimes it's not, because they say, yeah, we're going to machine that out, or it's in a non-critical part of that component. That's always a good outcome if you can get that. But it's manufacturing, and defects and unplanned things like that happen. It's unavoidable. It's the nature of the process. I would say those are the ones that are the most challenging. When you have multiple steps, you got to trace back through to try and figure out the root cause, because part of finding the root cause is wanting to, avoid a repeat of the same scenario happening again. Yeah.
No, that sounds like, especially during the process, was probably very difficult and challenging, but also rewarding when you solve it.
Yeah, and particularly rewarding when you know that you can put something in place to prevent it from happening again.
Yes.
So, it's can I save the piece, and can we make a learning experience out of it as well? So kind of those two-pronged approach or benefit to it.
Yeah. Now, with supply chain challenges and shifting regulations, how do you see the role of metallurgical expertise kind of evolving in steel production?
Well, I would say in those two areas, steel always has this challenge of people wanting to commoditize it. And it's actually, once people learn and know more about it, it's a very technical product. And there's a lot of specifications that go into the different grades, especially nowadays. We have advanced high strength steels. We have these low carbon steels that have been made for, a century or so. But the range of grades and materials, even just within steel, and I'm sure aluminum and titanium and copper, all these other metals, they're also advancing. So to just lump it into one category, that's probably a little bit of kind of the danger zone there, and not leaning in and appreciating the technical aspect of it. So I think as people are looking, oh, where can I buy this the cheapest? They might go to a source that, yeah, that's the cheapest one I can get, but then they get burned and they don't even quite understand why. So being able to refer to somebody with some metallurgical expertise or some experience in that area is going to be critical to probably eventually meeting the downstream quality that the end product is requiring.
Yeah, no, that makes sense too. And I think we commonly will try to lump things all in one thing. It makes it easier, right?
Right.
But really getting down to finding how to differentiate in between those, different types of steels and aluminums and metals in general.
Sure. Yeah. I mean, the steel that you're going to use for making line pipe in an oil field is going to be completely different than what you're going to be using for stamping out car doors and hoods and things like that. So, making sure that things are still appreciated for the technical individual products that they actually are is, I think, where the metallurgy comes in and plays a critical role in all of that.
Yeah, absolutely. And then final question I wanted to ask too. So you have the technical background. How was that transition to sales, and kind of like, how do you feel about that? What kind of propelled you to sales, or was it just kind of just happened?
Yeah. So, I mean, I guess to answer the first part of your question, the technical background is always useful in a sales capacity, because working with customers, it allows me to be able to kind of quickly relate to their issue. If I don't even know exactly what it is, I know enough about that process or that product that we can very quickly get to the same page at coming up with a solution or finding, a product that or a service that's going to work for them. And in terms of how I got to the sales side of it, I suppose on the metallurgy aspect, I started my career more in the technical and the quality roles. And then I always enjoyed going to customers in terms of kind of the technical support. If there was an outside salesperson and suddenly it got beyond a conversation they were able to handle, and or there was a customer that had a claim or some issue that had to be resolved, to me that was, kind of running to the fire, but I enjoyed that scenario.
Yeah.
So that's where I eventually made the transition over to the commercial side, because it was just something that I enjoyed, working with customers and helping to solve those problems that were a little bit more than just a commercial resolution, that actually needed some technical resolution in addition to whatever the sales or commercial aspect of it was as well. So I really enjoy the combination of those two.
Yeah, that's awesome. And yeah, pretty much once you switch to sales, it's like it's hard to go back to other jobs, I feel like, or positions.
Yeah, but at the same time, I utilize, my technical background and knowledge all the time, every day, whether it's giving a presentation at a conference. If I'm doing that, then there's a technical nature to that. It's not
Yeah.
just
Oh yeah.
the sales pitch, but it's, how do these products work? How does this knife cut through your steel better, or whatever the presentation might be.
Yeah, absolutely. And I think for the sales side, it's getting into the shops is the fun part too. Seeing how, I mean, these are the shops that make up America, right? Makes up our economy. So getting in there, meeting people and seeing the workers and stuff is just always inspiring. And I never get tired of that.
Sure. Yeah. Any manufacturing process out there, whether it's steel, food manufacturing, tires, I don't pick the product, but manufacturing in general is always interesting to me. And I'll never turn down a chance to go through whatever manufacturing operation it is.
Yeah, absolutely. And we are out of time, Brian. Thank you
All
so
right.
much for the
Great.
expertise that you bring to the industry. For those of you tuned in, stay tuned for more industry leaders like Brian.
All right. Thanks, David.